Hello, welcome to the lecture of structure of atom. Till now, we have studied about the discovery of electron, proton and neutron, Dalton's atomic theory, Thomson's plum pudding model and Rutherford's nuclear model of atom. Now we will study about some terms which are important for knowing the chemistry of different types of atoms, like atomic number, atomic mass or mass number, isotopes, isobars, etc. Before starting these topics, we will see about the Rutherford's atomic model once more. So, Rutherford had performed an experiment known as Rutherford's alpha particle scattering experiment. We had discussed previously that in this experiment there was a lead box with a hole in it, and this lead box contained a source of alpha particle. It was kept in a lead box to minimize the deviation of alpha rays. When these alpha particles were released, that is alpha radiation were released from the radioactive particles inside, it travelled through this hole in a straight line and bombarded on a gold foil kept at a distance. On the path there was one lead plate kept with a narrow slit. It minimized the deviation of alpha radiations more. Around the gold foil there was a circular screen of zinc sulfide which was fluorescent. So, what happened in this experiment? When the alpha rays strike on the gold foil, it will either pass through it deflected or undeflected and strike on this zinc sulfide screen. The positions on which the alpha radiations strike on this screen will show the type of deflection or show what happens to the alpha particle inside the gold foil. So, some of the rays passed through the gold foil undeflected and hit on the zinc sulfide in an undeflected position. From this, Rutherford drew the conclusion that for the undeflected rays, they did not pass through any barriers. That's why they remained undeflected. So, from this, Rutherford gave a postulate that most of the space inside an atom is empty. Some of these rays deflected at small angles like this. The deflection was due to some kind of repulsive force. Deflection was due to repulsion, and some of them deflected at even higher angles, like angles greater than 90 degree, and very few of them, like 1 in 20,000 particles or alpha rays, deflected 180 degree, that is they strike on the gold foil and retraced the path through which it had followed at first. So, they retraced the path, that is 180 degree deflection. From this, it was concluded that the deflections increased due to the repulsive forces. Now, alpha particle is helium with a charge of +2. So, since like charges repel, so alpha particles are positively charged. So, they will be repelled by something positive, repelled by positive region of atom. So, from this the conclusion was drawn that there is a positively charged region in an atom called the nucleus, and the 180-degree deflection was due to a direct collision or direct approach to the nucleus. Like if this is the nucleus, this is the atom and this is the alpha particle. So, when these alpha rays travel like this away from the nucleus, they will pass undeflected. But when they approach the nucleus, like when they are near to the nucleus, they will deflect. And when they approach more, they will deflect at a greater angle. And suppose this approaches the nucleus directly, then it will get deflected in 180 degree. So, the conclusion was that the shorter the distance between the alpha particles and the nucleus, the more will be the deflection. That is, as the alpha radiations approach the nucleus, the deflection will be more, because the positive charge will act and will generate the repulsive force in much greater magnitude. But the particles, that is the alpha radiations and the nucleus, they will never collide, because whenever alpha rays approach the nucleus and they are somewhere near to the nucleus, there will be a repulsive force acting on them, and so the nucleus will cause the deflection of alpha radiation, but they will never collide. So, there is a certain point to which the alpha particles can approach the nucleus and it cannot approach farther from that point. So, that point is called distance of closest approach. We had studied about the derivation of distance of closest approach. So, what was that? Suppose this is the nucleus and this is the alpha particle. So, alpha particle is approaching the nucleus in a straight line, and at certain distance, suppose at this point, the alpha particle stops. Beyond this point, it cannot approach. So, let us consider the distance between this point and the nucleus is d. So, initially the alpha particle was having a mass of m and a velocity of v. So, when it reaches this point, then it stops. So, now velocity becomes 0. What is the formula of kinetic energy? Kinetic energy equal to half of mv square. So, if at this point velocity of the alpha particle is 0, then kinetic energy will also be 0. But by the law of conservation of energy, kinetic energy will be converted to electrostatic potential energy. Why electrostatic potential energy? Because it is the energy between two charges. So, what was the formula for that? K Q1 Q2 by R, where K is the constant, it has a certain value, and R, this is the distance between the two charges, in this case it is d, and Q1 and Q2 are the charges of alpha particle and the nucleus. Alpha particle has a charge of 2e, since it is plus 2 charge on helium, so it is 2e, and the nucleus will have a charge of Ze, where Z is the atomic number of the atom or the number of protons of the atom. So, kinetic energy will be equal to this energy. So, half mv square equal to, if we put the values, k into 2e into Ze by d. So, this becomes 2k Ze square by d. So, d will be equal to 4k Ze square by mv square. From this, we can calculate the value of distance of closest approach. So, this was the Rutherford's model and the distance of closest approach. So, now there are certain important terms that we have to discuss in this class. So, these are the terms we will learn about. First, atomic number denoted by Z. The second one is atomic mass or mass number denoted by A. According to this, there are some few more terms that we will see today. They are isotopes, isobars, isodiaphers, isotones, isoelectronic species, and isosteres. So, if you remember, we had some introduction about isotopes and isobars when we had discussed about the Dalton's atomic theory. We will see in details all these things. So, we will start about atomic number and atomic mass. So, an atom has two important parameters. They are atomic number and atomic mass. So, what is atomic number? So, in a neutral atom, since the atoms are always neutral, if the atom has a charge, then they are called ions. Atoms are neutral, ions are charged. They are of two types: cations having positive charge and anions having negatively charged. Okay, but atoms are always neutral. Atoms have a charge of 0. So, what is atomic number? atomic number is the number of protons or number of electrons in a neutral atom. By textbook, atomic number is defined as the number of protons, because the number of electrons may vary according to the charges of the ions, because electrons are transferable. Atoms can release electrons, they can accept electrons, so number of electrons are variable, but number of protons generally remain constant. So atomic number is defined as the number of protons. But as we know, in neutral atom, number of protons is always equal to the number of electrons. In atom, number of protons are always equal to the number of electrons. Cations are formed when electron is taken out from an atom. And anions are formed when atom accepts an electron. Okay. So this is the definition of atomic number. Now atomic number is denoted by Z. So Z represents the number of proton as well as the number of electron. Okay. Now that's why we had seen in this derivation that the charge of nucleus is Ze, because that is the atomic number, that is the number of proton. Okay. Now the second one is mass number or atomic mass. What is mass number? Mass number is the sum of number of protons and neutrons in the nucleus of an atom. Mass number is the sum of the number of protons and neutrons in the nucleus of an atom. This is denoted by A. So A is equal to number of protons plus number of neutrons, where Z is equal to number of protons or the number of electrons. So how we get the number of neutrons? It is A minus Z, that is atomic mass by minus atomic number, and an atom is denoted like this. Suppose this is some element, so atomic number is Z is written at the bottom and mass at the top. So we will further study its details. Thank you.